Exercise number 2 is going to be about network matrix. As usual, as we have seen already, we don't want to put all the commands in the command window and have to type or redo them all of the time. So what we do, of course, we work in scripts, and by pressing open a new script, we want to have a new script file ready for our next exercise. And we can start it with the command CLC, which is clear command window, and just make sure that the command window, which is visible here on the right side of my MATLAB screen, is actually free of any previous things. You can also check my workspace is condensed here on the side. From the previous exercise, we have things in the workspace. If we want to get rid of them, we have to use the command clear, and it means now everything is tabula rasa. So the thing what we want to do first in our plot, I'll save it. This takes a short while, and we call it matrix exercise. To save it, I keep it here on the desktop, and the first thing that we want to do is generate a matrix. Now there's various ways of generating a matrix, and we start by doing it in a very simple way, namely defining an array in square brackets. So a matrix is a two-dimensional array, and what you have learned, if you have seen the materials, that network matrices must be square matrices. So the number of elements in a row and the number of elements in a column need to be the same. I'm just going to fill up one by hand, and this is 1, 1, 0, 0. If that will be defining my first row. For the second row, I have 1, 0, 0, 1, 1. That completes my second row. Third row will be 1, otherwise zeros. And that shouldn't be a comma, must be a semicolon to separate rows. Next one will be 1, 0, 1, 0, 0. No, one more, it will be 0, 0, 0, 1. So let me do this first. This is my fourth row. Must be 4 zeros. And we can go to the next side. If I open my window that you can see it more nicely, then will be eventually the last row. This is now the one that I had written before, and we have a 0 in the end, and that completes our matrix. And what you can see is that we have 5 rows with 5 columns each. So what we can do is, if we take away the semicolon and execute this, we can visualize the matrix will be displayed on in our command window on the right-hand side. And you can see how what I typed on the left-hand side in the script translates into a proper square matrix on the right-hand side, which is now assigned to the variable mm. Having done this, we can, of course, do that in many different ways. And I just want to highlight that if you want to set up a matrix where most of the entries are 0, so where there are many zeros and only a few ones, there might be another way of doing this. If I define a matrix MM0, namely starting with not putting in all the numbers, but starting with a function called zeros, which is just for this purpose. Namely, it takes as many rows and as many columns as you tell it, for example 5, and it creates a matrix that is filled with zeros only. So if I put a semicolon here and only execute this part of the code here, what you can see is that I have created a matrix which is all zeros already. And I hope that each of you now knows how to assign different values to those elements that are supposed to be different from 0. For example, if you want to fill in ones where you want to have a connection, say you want to have a connection from the first row to the second column, what you can do is you need to assign first row, second column as a value that is different from 0, namely, you can assign it to 1. And if I do this, you can see that my previous matrix filled with zeros has changed and actually now contains a 1 in the place where I have assigned it to be. So that's a good way of doing it. So now you can also be filling in your own matrix. And because somebody had a problem with this, if elements 2 and 3 in the first row are supposed to be 0, at the same time you can also do that by using the conventionality of putting arrays in brackets. So I have now expanded this and I have said in the first row take column 2 and 3 and assign it the value of 1. And if we do this on the command window, what you can see, both are now turned to 1, and this makes it a little bit more comfortable to start with. Right. One thing that we now want to be able to do is if we have a network matrix, for example, if I just take this away, the previous ones that we have created and assigned to the array M, clearing the command window MM, we would like to find out what is the number of nodes that represented by that matrix and what is the number of edges represented by that matrix. Two numbers that MATLAB might be wanting to access later on in the course. And so when you want to do this, you need to know how to get these numbers. Now, an easy way to find out how many nodes there are is to just check the dimensionality of that matrix. So if you check the size of MM, what you can see, the answer is 5 by 5. And so it means this network is created for representation of 5 nodes. If you are interested in getting the number of nodes, you might want to add the second optional argument, namely the size of MM,1, because that will then return you only one number, and this is the size of the node, so the number of nodes. If you want to assign it a value, then you can say number of nodes equal to 5. And there you have it in a nutshell. And another thing that we might want to check is the number of edges. So how would we find out how many edges there are in a certain matrix? And the command to do is to first use find, because we can check find to look for certain elements in that matrix. For example, those that are 1 equal to 1 or that are larger than 0. And because the entries can be different from 1, we might want to check where is this matrix larger than 0, means we will miss out all the zeros, but we'll get information about where this matrix is different from 0. So if we do this, we get a set of numbers. Now, this is something that we have to understand. Why do we get a set of numbers? What does this tell us? This tells us where in the matrix is the element located that has been assigned a value that's different from 0. And in order to understand this, we must go back and take a look at our matrix MM again. If you just allow me to display this matrix MM again, then there's 2 ways of addressing the first elements. I hope you can see that on your screen. So the first way to see the first row and the first column is to write down MM of round parentheses 1, 1. So that, of course, gives you the answer 0 because the first element here, 1, 1, is equal to 0. Another way of getting the same element is asking MATLAB to return you the first element of that matrix, and it's also 0. So we have two ways of accessing this, one using two indices, 1, 1, and another just using one index. So how is the matrix indexed in the second case? It's indexed from 1 to 25, all the way down, and the only thing that we need to know when it goes, whether it goes via rows or whether it goes via columns. And of course, because the elements here and here are the same to those here, so we want something that is distinct. So the fourth element in the first column is 1, but the fifth element in the first row is 0. So let's try to find that out. And we get this element by looking at element 5. And if the element 5 is equal to 1, it tells us that MATLAB actually goes column-wise. So it goes down the first column, and then the element number 6 will be, if I go back, will be first element of the second column. So that's how we can find out what number of edges means. Namely, it tells you the index according to this way of accessing the elements in that number. And you can see we have a certain number of indices that are all larger than 0. So just knowing how long is that array that we return from the find function will also give us the number of edges in that. And how do we do that? What we can do is, now I give it a different name. So actually the first one was not yet the number of edges, but it was number of edges. It was actually the indices where the edges are. And to find out the number of edges, we can use the command length. Length, and you say the length of which array? The length of this array. What is the length of this array? Now, if I execute it, tells you the answer is 9. So there are 9 elements in this array, and this lets you find the number of edges in the network matrix. So now we have basic information that we need. We need to set up a square matrix. We have seen how to do that, how we can put in the ones in the places that we want to do. Where we want to have connections displayed, we have the information represented here by ones. Otherwise, it's 0 means there's no connection. And an important feature here is that MATLAB prefers to have no information on the diagonal. Their biograph requires actually that there is no self-connection of an edge, of a node to itself.